Dear students, in continuation of my teaching video, the second part, I start the first chapter of physical chemistry solution. Solution, as you go in syllabus part as published by CBSE, this syllabus divide in 5 parts. The first part is what is solution, type of solution, and the most important part is the expression of concentration. The second part, the solubility of the gases in liquid, Henry law. The third part is the liquid-liquid solution, Rod's law. And fourth part, we discuss colligative property. And the fifth part is the abnormal molar mass and want of factors. Now, first of all, we start the first part. What is solution? You know from the very lower classes, when the two and more component are mixed together. But here two conditions are very important to define. One is the homologous mixture and the second one is the chemically non-reacting substance. So if a solution prepared by the two component, then it is called binary solution. And if it is three, it is called ternary solution. But in our syllabus, we mainly focus on binary solution. A solution consists of the two component. One is the solute, other is solvent. You are very familiar with the sugar solution, lemon juice solutions that is daily used in our home also. So how we identify the solute and solvent, which one is solute, which one is the solvent? It's very easy if you recall the simple term, those which are smaller in quantity and those are larger in quantity. If it is a smaller in quantity, that is solute. It is larger in quantity, it is called solvent. Now, for example, if you see sugar solution, always water is large and sugar is smaller in quantity. So sugar is solute, water is the solvent. If you take lemon juice water, the lemon juice in smaller in quantity and water is larger in quantity. Now on the basis of the components, the solution are mainly divided into three categories. That is the gaseous solution, liquid solution and solid solution. Now see, that is the air is a mixture of different gases. So if the solute is gas, solvent is gas, if liquid and gas, you see these are the example given in NCERT also. So we can easily find out what are the different type of the solution. Now our major concern about the second part of this chapter, that is called expressing concentration of solution. Now one very interesting question is come in our mind. What the difference between concentration and strength of the solution? Concentration of a solution is the amount of the solute dissolved in a known amount of the solvent or solution, whereas the strength of the solution is the amount of the solute in gram present in 1 liter of the solution. This concentration expressed by using percentage, the percentage by mass, percentage by volume, mass volume percentage, as well as the part per million, that is also called ppm. Whereas the strength of the solution, molarity, molality, normality and mole fraction. So we discuss one by one. But before starting this topic, it's my humble request to everyone to just see what are the keyword used and you use all these in whole the chapters. For example, molarity is expressed by capital letter M, molality small letter. If the question written W by W, it clearly indicate mass of the solute and mass of the solution. W by V, mass of the solute divided by the volume of the solution. If V by V is the volume of the solute and volume of the solution. ppm, it's a part million. Now again you come, these notation are very important. Small na, that is, always remember the n means mole and mole means we discuss later on. So Na, if you just add one thing, A means solvent and B means solute, then it is easy to understand all formula, because this is the very important part for the numerical problem. In previous video, I already discussed how the physical chemistry divide into two parts, theory and numericals. Similarly, you see here WA, that is the mass of the solvent, WB is the mass of the solute, MA is the molar mass of the solvent, MB the molar mass of the solute, XA, that is the mole fraction of component A, and XB mole fraction of the component B. Normality is denoted by N, and formality also we discuss here, that is F, that is the formality. Now we discuss one by one. First we discuss percentage. So a very simple formula is there. If we want to calculate the mass percentage of a component, so very simple, mass of the component in the solution divided by the total mass of the solution multiplied by 100, we get the mass percentage of the component. Suppose that a solution is made up of the two components, we can easily calculate the mass percentage of solute and mass percentage of solvent. Volume percentage, that is the volume of the component divided by total volume into 100. Similarly, mass by volume percentage, so mass of the component in solution upon the total volume of the solution. So these three formula, if you go in text questions of the NCERT, I mentioned the question number also in the last of this chapter. So you can solve the question based on all these formula. If the solute are very smaller in quantity, then we use part per million, that is the mass of the component A upon mass of the solution multiplied by 10 raised to the power 6. So this is the one part how we express the concentration. The other part is strength. In strength, first of all, we take molarity. It is denoted by capital M, and the very simple definition, number of the moles of solute present in 1 liter of the solution. So if you come in formula form, that molarity equal to moles of solute upon volume of solution in liter. So if you know the notation, very important part of this topic is how we know the moles of the solute. Moles, that is the mass upon molar mass, as details we study in class 11th also. So the mass of the solute is denoted by WB, and the molar mass of the solute also denoted by MB. So if you just start writing from the beginning what is the moles of solute, you can easily come to the very easiest formula, and that formula is the molarity equal to WB into 1000 MB into volume of solution in ml. But here you must mention this is the mass of solute and this one is the molar mass of solute. So if three things given to you, that is the mass of solute, molar mass of solute and volume of solution in liter, you can easily calculate molarity. Here one thing also important, that molarity depends on the volume, and volume can be changed with the change in temperature. Therefore, a molarity change with change in temperature. The second thing is molality. If you come to the molality, the number of moles of solute present in 1 kg of the solvent. Here is the mass. So, molarity, it is represented by small m. Moles of the solute divided by mass of the solvent in kg. And if you just come to the formula, because I already discussed the notation, WB in 2000 MB upon WA. Here WA is the mass of solvent in gram. Mass of solvent in gram. The two things I already discussed earlier. WB mass of solute, MB molar mass of the solute. So here I already mentioned WA, that is the mass of the solvent in gram. But one very interesting part is there. If the percentage is given, then you can easily calculate molarity by using this formula. For example, one question is there. Calculate the molarity and molality of the 15% of sulfuric acid. The density is given 1.10 gram centimeter cube. Now, if the 15% is given to you, that means you use the second formula, and second formula is percentage multiplied by 10 multiplied by density upon the molar mass of the solute, without converting the mass into volume, because percentage is given. It means 15 gram is the solute, 85 gram is the solvent, so total mass is the 100. So again we use the formula density equal to mass by volume. So we calculate the volume, mass divided by density. No need here. You directly use this formula, use the percentage, density and multiplied by 10 and total divided by molar mass of the solute. You easily calculate the molarity. Now here one thing also very important. In case of ionic compound like sodium chloride, calcium chloride, we use formality, and in place of molar mass we use formula mass. That is the only difference between the molarity and formality. The normality is not in our syllabus, by just I mention here for your knowledge. There is the only difference is that we use here the equivalent mass of the solute in place of molar mass to know the normality. So again you see WB is the mass of the solute multiplied by 1000, equivalent mass of solute and volume of the solution in ml. You also calculate the normality. But here one question is very important. How we know the equivalent mass? I just mentioned two examples here. There are so many examples you can, if you want to know, I take the much more time separately for the normality, but as per our CBSE, it is not mentioned in our syllabus. I see equivalent mass of element, that is the atomic mass of element divided by the valency of the element. Equivalent mass of an acid, that the molar mass of acid divided by the basicity of the acids. So like that, if you want to calculate equivalent mass of equivalent mass of base, then it is molar mass of acid divided by acidity of the base. So these four things is very important for the numerical point of view: molarity, molality especially, and when molarity treated as the formality, and normality I just mentioned here, it is not in our syllabus. Now come to the fourth one, mole fraction. Actually, mole fraction is a fraction obtained by dividing number of moles of the constituent by the total number of moles of all constituent present in solution. Suppose that it is a binary, no problem. It may be ternary. So here, if it is a binary, then mole fraction of component A equal to Na upon Na plus Nb. Suppose that it is a ternary. So here we mention plus Nc also. Similarly, the mole fraction of component B, that is the Nb, Na plus, means lower portion in each case are same, only the first part is changed. Second, no need to calculate both because Xa plus Xb comes 1. So if we calculate mole fraction of one component, the other can be easily calculated by using this formula. Now this topic is not only important for theory, it also important for numerical also. So relationship between the volume and molarity and normality, this is the general formula you see, M1 V1 equal to M2 V2, or if you change into the number of moles, the second formula. In case of normality, we use N1 V1 equal to N2 V2. If you come NCERT, these questions are purely based on today's topic. Example 1.1 to 1.3, in-text 1.1 to 1.5, exercise 1.1 to 1.7. I already discussed these things, but I again repeat, this is the very important parts. Molarity depends on the volume of the solution, hence it change with change in temperature, but molality depends on the mass of the solvent, hence no effect of the change in temperature. Now I just give one example of the numerical problem, because in a numerical problem, first duty of every student, read the question 2 times. For example, you see, calculate the molarity and molality of 15% sulfuric acid given density of H2SO4 equal to 1.10 gram per centimeter cube, and the molar mass of sulfuric acid is 98 gram per mole. Now here very important parts is to identify the numerical 15% sulfuric acid. Here Wb is 15 gram, Wa is 85 gram, Mb is 98 gram per mole. Our target is to calculate first molality, because the formula is Wb into 1000 divided by Mb into Wa. You see, Wb is given, Mb is given, Wa is given. how it is easy to solve the numerical problem if you read the numerical honestly. Similarly, molarity, as you know, the molarity volume is required. So total mass of solution is 15 plus 85, it's come 100 gram. So volume equal to 100 upon 1.10. So one formula, as I discussed, WB into 1000 divided by MB into volume in ml. You can solve this problem. WB is 15 into 1000 divided by 98 into 100 upon 1 by 1.0. But here I already mentioned, if the percentage is given, that can be also solved by using percentage into D into 10 divided by MB. In both cases, you get the same answer, 15 into 1.10 into 10, 1.1 into 10 divided by 98. So if you solve this part and this part, you get the exact answer. The numerical problem is totally depends upon how you read the question. Divide the question in two parts. What are the given and what are the requireds? Then in chemistry, numerical problem is totally based on practice. When you have to practice all these questions from the NCERT, now you take more examples, but you solve it. When you solve it, then only your confidence, yes, we can easily solve the numerical problem in board examination or in competitive examination. So today is the first part I completed. In the next video, I take the second part, that is solubility of the gas